I think that what you got to do is be able to sort of like identify how you're gonna prepare this. So first thing first is that there's like this whole size thing. So the thing they say is that the most efficient way is sort of like a mathematical term or power series. So and that is always like doing a double, like 1 become 2, 2 become 4, so it's always double. So um and that surprisingly, like when you have the 8, it's always like of the previous, 2 times of the previous, so it's always 2 times of the previous. So I mean, if you go next for this one, it's gonna be 16, right? And I don't know, man, like they put it like double for it, and that I think it's really important because it just tells you why they usually achieve this number of saying that you got the double for your previous. So when you double your previous, it knocks off the balance of like balancing between creating too many spaces and then creating enough spaces for you to add later on. So I'm trying to like understand like what does this mean. Size 8 array is 15. 1 2 3 4 5 6 7 8. Can you count, sir? The size 8 array is 8, it's not 15. What do they even mean by 15, to be honest? I'm not so sure, like really. So but on the previous episode, it's talking a lot about you know trying to get your pushing of the value in. So they were like talking about big O of how much to be able to push a value. So obviously if there's an empty space, you push a value, it'll be big O of 1. And then if you want to insert something into the middle, obviously you need to big O of like n, because you need remove the last two values, and then you insert the new value in, and then you insert the two values again. I'm not too sure like the overall mechanics, but intuitively speaking, it'll be that way. So um like yeah, it's a mathematical term for this to actually always like doing multiply by 2, but there's um you push a value in for one value in, I think that's 1. You put to, I don't know, like this thing is to be able to actually read this one value, or is it the operation of like pushing the value from here? I'm not too sure, but definitely this one is like saying like um, how many elements are there in the array. So here is like 4, here is 8, um, and I'm not too sure why they do this, like really, like size 8 array, I obviously got 8 elements. Why are you telling me there's 15? Are you telling me the next operation there's like 15 elements in it, or what? And I do know it's like 2 times of the previous number. So say for example for this 4, if say you say you are taking into respect into this one, you're gonna like 2 times 4 to get the 8, right? Very intuitively speaking, but because I don't know what are you trying to talk about over here, I'm not That's why I'm not talking about the big O of stuff. So I think it all comes down to the foundation. If we start to actually understand the foundation of things, then we can start applying. Okay, is this the big O of what, right? Then we get more interested. And then on the later half, I think it's like they give off like the graph of how powerful of big O of n squared as opposed to big O of n. Like you're comparing a constant and the power of n. It's drastic to an extent that you even consider constant to be 1,000. You don't even care about that, right? That's how powerful the power of n is. And then end off with like sort of like a table telling you about okay, so when you want to push a value in or you want to remove a value in, you want to read a value big O of 1, but if you want to insert into the middle, big O of like n. And as I like talked about earlier, I don't really get how it become derived in that way, but yeah, so everything comes to an end.